All right, I'm going to work on your review for Chapter 6, and we're looking at electron configurations in this review, so I want to try to get you ready for the exam next Monday and Tuesday. First question says, when given an element, be able to determine if there are any unpaired electrons. The best way to do that at this point in your life is to draw that electron configuration. So if you go to neon, it has 10 electrons, and I'm using my periodic table, and you will be using the one we give you. You will not have your colored one, so you need to know how to read it. And I know that I start out with 1s2, 2s2, 2p6. I've placed all 10 electrons because 2 plus 2 is 4, 6 more is 10. None of these are unpaired because if I draw it, there's the 1s. There's the 2s. And then the p's fill up one at a time. So there are no unpaired electrons. Okay, now I want to go to nitrogen, so I'm going to look at my periodic table. There's nitrogen. There's 7 electrons there, so I'm going to draw out my orbital diagram. 1s takes care of 2 electrons. 2s takes care of 2 more electrons. 2p, 1 goes here, here, and here. Hopefully you understand that a pair is 2. This one is missing a mate, missing a mate, missing a mate, so there are 3 unpaired electrons for nitrogen. I'm going to change colors. I'm going to go to rubidium. Look at rubidium on the periodic table. Rubidium is right here. It has 37 electrons. Now, if you think about it, rubidium is on 5s. This column has 1, 5s1. So there's 1 electron in this 5s, so it has 1 unpaired electron. I got that strictly from reading the periodic table because all the way up to 36, they're all paired. I come down here, place 1 in 5s1, and I have 1 unpaired electron. If you don't understand that, draw it out. So let me show you how to do that. So rubidium has 37, I think is what I told you guys? Yes, 37. So I'm going to look at it. And I'm just going to work down here because I have more room. So there's my rubidium, 1s, 2s, 2p. And then I go to 3s. After 3s, I go to 3p. Then I go to 4s. And then after I do 4s, I'm going to go to 3d. Oops, let me get rid of that. After 3d, then I should go to 4p. There's my 4p. And then finally I'll be at 5s. And that's kind of, I've got them spread out, so I really should, let me just redraw that so they're not spread out, and it makes it a little bit more, makes it a little more continuous because that's kind of here, there, and everywhere. So let me do it again. Here's 1s. Here's 2s. 2p. 3s. 3p. 4s. 3d. After 3d comes 4p. And the final one, the last one is going to be 5s. I need to place 37 electrons. So there's 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, and then 5s has the 37th, and there's one electron unpaired. Now, that took forever to do. All I really had to do was go back to the periodic table, look at this, and say, okay, I'm in rubidium. It's in group 5s1, or orbital 5s1. All the other electrons are paired. There's one lone paired electron. Makes your life a lot easier. Okay, so rubidium is done. Potassium is my next one. Potassium is right here. It's in 4s1, so it's going to have one unpaired electron. Let me show you how I know that. So I'm going to do potassium, and I'm going to do potassium in this lovely shade of burnt orange, if such a color existed. So there's 1s, 2s, 2p, 3s, 3p, and finally 4s. So I'm going to fill them in. I want 19, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So if you look at this, there's a pair. This one is my lone electron, so there's one pair in the potassium that are alone. Electron is alone. I'll go back to the periodic table and talk about that one more time with you. If you don't want to do all this drawing it out, use your periodic table. Here we are. Potassium is in this column. It has one unpaired electron right there. Okay? Now it says determine how many valence electrons are in an atom. I'm going to clear the board, and I'm going to work with those same ones. Okay, so neon, if I go over here, neon is in this group right here. Everybody in this group right here has 8 valence electrons. Helium doesn't because it can only have 2 electrons. So I'm going to go back and I'm going to say, well, neon had, 8 valence electrons. Go to nitrogen. Nitrogen is right here. There are 5 valence electrons. 1, 2, 3, 4, 5 valence electrons. So everybody here has 5 valence electrons. Rubidium, we just talked about rubidium. It's in this group right here. Everybody here has 1 valence electron. 1 valence electron. And then potassium, same group, 1 valence electron. So there's 1 valence electron, 2, then I skip over to here, 3. The reason it has 3 is there's 2 from the S's and 1 from the P, so that's 3. 4 here, 2 of them are S's, 2 of them are P. 5 here, 2 of them are S's, 3 of them are P. 6 here, 2 of them are S's, 4 of them are P. 7 here, 2 of them are S's, 5 of them are P's. 8 here, 2 of them are S's, 6 of them are P's. So there's 1 valence electron for potassium. Be able to determine the location and identity of an element when giving a generic electron configuration. This N right here and this N right here stand for the energy level. It can be anywhere between 1 and 7. We don't even care. So I have 2 electrons here and 4 here, so I'm looking for something that has 6 valence electrons. Wow, I don't know what that was, but it scared me to death. 6 valence electrons. How did I get that? I added up the 2 and the 4. 2 plus 4 gives me my 6. Where did I get those from? That's 2 electrons there, 4 electrons there. So I go back to my periodic table and I find the column with 6 valence electrons. It's this column right here. So it's either 16 or you could call it 6A. And the atomic number could be oxygen 8, sulfur 16. You just need to pick one out of here. That's why it's generic. It doesn't tell you which energy level to pick. It just says find one that has S2P4. So it's this little rascal of elements, this column of elements right here. So that's going to be either 16, group 16, or some people call it 6A. And it starts with oxygen. So if I ask you, you would tell me it's oxygen and it has atomic number 8, or you could pick one of the other ones. All right, 2 plus 6, I'm looking for 8 valence electrons here. So I go and I pull my periodic table back up again. And I say, well, 8 valence electrons is over on this far right-hand side, so it could be any of these. It's group 18 or 8A, starts with neon and goes through radon. So 8 valence electrons is group 18A or 8A. And it's neon, argon, krypton, radon, any of these in the noble gases. Right in there, xenon. Okay? Then I look at this next one. It says in S2 in P1, so that means I'm looking at 3 valence electrons. 2 plus 1, I'm sorry, let me say that again. 2 plus 1 is 3 valence electrons. So I go to my periodic table, and I say 1 valence electron, 2 valence electrons, 3, so it's group 13 or 3A. 13 or 3A. Group 13 or 3A. And the names would be boron, aluminum, gallium, indium, and thallium. Any of those right there. All right, so let's move on down. Okay, so we're going to move on down. We've already done numbers 1 and 2 and 3. All right, let's see what we can do here. It says, when given a complete electron configuration, be able to determine the name and atomic number of the element depicted. Add those superscripts. That's 10. Element 10, if I looked at the periodic table, is neon. Add these. 2, 4, 10, 12, 18, 20, 22. Number 22, if you look at it, is titanium. So you would tell me element 22, and then you would tell me the name, titanium. You know, the maximum number of electrons are going to be placed on the first 4 energy levels. So I'm going to say 2 times 1 squared tells me that 2 electrons can be put on the first energy level. And I'm going to go ahead and do all 4 of them. 2 times 2 squared is 8, so 8 electrons can go on the second energy level. Third energy level, 2 times n is the energy level number 3. So 3 squared is 9. 9 times 2 gives me 18 electrons for the third energy level. And then for the fourth one, it's going to be 2 times 4 squared. That's 16 times 2 is 32 electrons on the fourth energy level. All right, I'm going to stop this recording, and then I'll come back and we will start on number